Good morning, students. Today we are going to practice a limiting reagent problem from topic 14, stoichiometry calculations. Consider the reaction in which 4 moles of iron react with 3 moles of oxide to produce 2 moles of iron 3 oxide. If 6.4 moles of iron are allowed to react with 5.9 moles of oxide, what is the limiting reagent and what is the excess reagent? Before we begin the calculations, we must first look at the information that we have been given, which is that we have 6.4 moles of iron and 5.9 moles of oxide. We also need to set up the conversion factor that we're going to use in this calculation, which is the combining ratio of each of the reactants to that of the product. So when setting up this ratio, we have to remember to make sure that the denominator of the ratio is the moles of the reactant that we're computing for, so that we can cancel out the common units, and so as a result, we're going to get moles of iron oxide that is going to be produced when that reactant is fully used up. So in the case of iron to iron oxide, the ratio is going to be 4:2, because for every 4 moles of iron that we use, we're going to produce 2 moles of iron oxide. Similarly, for oxide to iron oxide ratio is 3:2. So for every 3 moles of oxide we produce 2 moles of iron oxide. And then we do the calculations. So to find out how much of iron oxide we are going to produce when we use 6.4 moles of iron, we set up the equation: 6.4 moles of iron multiplied by 2 moles of iron oxide over the 4 moles of iron, and the moles of iron cancel out from the 6.4 and the 4, and we are left with 3.2 moles of iron oxide. In the same manner, we do the calculation for the moles of oxide. We have 5.9 moles of oxide multiplied by the ratio, which is 2 moles of iron oxide over 3 moles of oxide. The moles of oxide cancel out from the 5.9 and the 3, and we are left with 3.9 moles of iron oxide. So as a result, we see that when the iron is completely used up and fully reacts, it produces 3.2 moles of iron oxide. And when the oxide is fully used up and reacts fully, it produces 3.9 moles of iron oxide. When we compare the amounts of iron oxide that each of the reactant can create once it reacts fully, we see that the iron produces less iron oxide since it runs out much faster than the oxides, and thus we conclude that the iron is a limiting reagent and the oxide is the excess reagent. And the maximum amount of iron oxide we can produce is 3.2 moles due to the fact that the iron runs out, and once the iron runs out, the oxide alone can't produce iron oxide. So it has to be how much both of the reactants can produce in maximum until one runs out. In this case, 3.2. Also, on a side note, we should take notice of the fact that initially we are given a greater amount of moles of iron compared to that of oxide, and despite that, the iron is the limiting reagent. It actually runs out faster than the oxide. So it's a side note to not get fooled that just because we are given a greater amount of one reactant than the other, we shouldn't just assume that the one with the greater amount is going to be in excess and the one with the lesser amount is going to be limiting.